Good afternoon, everyone. I'm happy to be with you today. My name is Greg Moore, and we're going to be talking about functional isokinetic training. Long name, fancy name, but we'll get into what it means and why it's relevant to strength and conditioning in almost all settings now. And that's what we're going to focus on in today's presentation. So to understand functional isokinetic training, resistance, we have to understand that within the spectrum of other resistance training options that are available out there. And the one that's most common is what we call isotonic resistance training, which is also known as dynamic external constant resistance. And we'll talk about each of these after we go through this and what they are and what they mean. Isometric training is another form of resistance training that most people have heard of and used at some level. Variable resistance training is another form of resistance training that's available in all sorts of markets. And then there's isokinetics, which of course we're going to focus on most today. So isotonic or direct external constant resistance. What does this mean? It means the weight remains the same throughout the full range of motion. The weight itself is not going to change. So free weights, example, the weight doesn't change while you're carrying it. Cable machines, same deal in general. The resistance doesn't change. There are cable machines that do. There's two phases in this type of resistance training, a concentric phase where the muscle is shortening under tension. Generally, the weight's going up against gravity at a point. And then the eccentric phase where the muscle is lengthening under tension. You have both of those in an isotonic form of exercise. The exerciser has to control the speed of movement, and there you can have momentum. So when you have momentum, this can cause lots of problems and potential injuries if we're throwing weight around, particularly if we don't have proper stabilization and control. And there's definitely an argument to say that for certain people, the use of controlled inertial movements, such as Olympic lifting, can be very, very beneficial, and there's no question about that. But for the average person, in fact, for the majority of people, if you don't do this correctly, even if you're an expert and you don't do it correctly, you're going to get hurt. So there's a lot of risk when we start using inertia and momentum when we're lifting weights. What are the acute variables for isotonic training? In other words, what do we manipulate over time to keep the person progressing? And some of them include how much resistance we're using. So the weight itself is one of the big variables. How many reps are we going to do, repetitions in a set of exercise we're going to do until we reach momentary muscular failure? How many sets of exercise? What is the work-rest ratio? Another big one. In other words, how much work relative to the rest in a ratio? How many exercises? And then, of course, the frequency, how often we're going to do this training each week. Isometrics, mostly used for stabilization exercise. So if you're doing something like a plank, for example, that's a great example of an isometric exercise. So there's no movement. So the good news is it tends to be very safe. But one of the challenges with it is you really don't know how you're doing. And in a plank you can, because you can judge your progress by how long can you hold that position. But in other isometric exercises, you really don't know how much force are you producing. So therefore, it's very difficult to understand, are you making progress? And it makes it more difficult to progress and adjust the program over time to keep you making gains. Variable resistance training. The most famous of this is Nautilus, which used a cam. You can also alter the length of a lever arm, or you can use bands or change. And what you're doing is you're changing the leverage or the load directly as it is moved throughout the range of motion. So you're changing it at different points, and your goal is to match the strength curve of the muscle, because of course muscles and joint systems can allow you to produce different levels of maximum force at different positions within the range of motion because of the way the joints and muscles work. So you have to, still in this type of training, you have to control the velocity of movement, because if you move quickly, you can generate momentum, you have inertia and momentum, and what happens is you're carrying it at some point, and again, you also have a big risk of injuries. Acute variables for this type of training, very similar to isotonic or DCR, so the focus for progression tends to be on the amount of resistance used in each exercise, but you have all those other acute variables we mentioned previously. Motorized isokinetic resistance, and this is true isokinetic resistance is motorized. The velocity is controlled and set by a motor, meaning the resistance comes through the motor system. So the slower the motor speed, the slower the movement speed that is possible in any exercise. You can't overcome the motor. It won't let you overcome it. The exerciser can never exceed the speed. So if the speed is set low, then you're going to feel a lot of resistance. So until the user matches the speed, the speed setting of the motor, and then tries to move faster than the movement speed, there is no resistance. Once the user matches the movement speed and tries to go faster, they're going to get back resistance automatically, and that resistance is going to be direct and proportionate to what they put into it. So it's automatically matching your output at each and every point in the range of motion. So it's very, very safe, because if the user experiences discomfort, pain, weakness at any point in the range of motion, they're going to ease up. When you ease up, it eases up. So it automatically matches your outputs, making it very safe and scalable for just about anybody. And this is a good pictorial example of the advantages of isokinetic training. Isokinetic training does perfectly what variable resistance cams and other mechanisms try to do, in that it matches output, your force output, with your resistance output. So you optimize the resistance. Instead of having a flat straight line of resistance, it can perfectly match your curve so that you're getting optimal overload throughout the range of motion. DMX Isokinetic Resistance, and that's what we're talking about today. DMX resistance machine, and you can see a picture of it in the background there, and we'll look at more pictures in a moment. The speed, or is called intensity on DMX, and it's controlled via an intensity dial. In fact, what that dial is manipulating is motor speed, and you can control it all the time, even when you're using preset programs. In the preset programs, there are preset defaults for this intensity setting, but you can override them, the user or trainer, at any time. So one of the key things to understand about DMX training is that DMX is a concentric-only isokinetic device. There is no eccentric phase. And what does that mean? Well, a couple things. Eccentric loading results in more muscle soreness and requires more recovery. And while there's certainly benefits to eccentric training, it can cause issues if we do too much, too soon, too fast, or at the wrong times with people. This is very significant for athletes, and because concentric-only exercise sessions can be added to a program to allow you to have an increased training volume, yet not overtrain the athlete, and to allow for in-season strength maintenance without overtraining. And we're already doing things like this in athletic training. So whenever you push a sled, if you've seen sleds that people are pushing and pulling, in essence, they're really concentric dominant. There may be a slight eccentric phase, but they're really almost purely concentric. So you can work very hard, but in terms of the muscle damage and the recovery, it allows you to work more frequently, harder, and still recover. So there's a real advantage using that at the right time within the training cycle for just about everyone. The lack of eccentric loading is also highly beneficial for beginning exercises and more fragile individuals, because you're going to safely gain strength without injuring muscles or tendons or experiencing any significant soreness. So some big advantages to that. Double concentric exercise, another interesting feature of DMX. It's going to allow users to perform double concentric exercises, such as a bicep curl and a tricep push down. So you curl up and immediately push down with no break or no change. Or another example would be an overhead press immediately to a lat pull down. So you're going to be able to do more work per exercise and per unit of time. And what does that really mean? It means you're going to get a higher caloric output associated with your weightlifting. And the reason this occurs is because the eccentric phase of typical resistance training is much lower intensity than the concentric phase, since the muscles are inherently much stronger eccentrically. You can lower up to twice what you can lift up. So when you're lowering a weight that you lifted, inherently, it's just not that much work, and the metabolic overload isn't there at all. So by eliminating an eccentric phase and having a double positive, we're greatly upping the metabolic requirement during that type of exercise. So really beneficial to the average user, particularly in a gym environment, who's looking to get stronger, quote, tone. We know that's not true, but they want to tone, and they want to obviously burn calories, and this is going to facilitate that while they're gaining strength. Isokinetic resistance, Typically what's going to happen with it compared to DMX is that your typical isokinetic resistance, which has been in the market for a long, long time, if you use single joint rotational movements only, so like a leg extension, a leg curl, internal shoulder rotation, external rotation. Because DMX is a cable-based system, it's going to allow compound functional movement, so it's going to allow more functional movements and infinite variations, as you'll see when you take a look at the video later on. We can literally move in any plane, in any direction, at any level, at any time, without having to change anything. So very, very functional application of isokinetic resistance. Really, really dynamic. The trainer in the exercise has control of the speed the whole time, and they can train at different speeds safely and eliminate many of your momentum-based injuries, which are one of the big sources of injuries in training. The other thing that's really unique about DMX is it features an Android touchscreen, so it's literally like literally your tablet, your Android tablet, very familiar to all users, easy, intuitive. Squeeze, punch, touch, double touch, all those things that you're used to doing with a phone and a tablet are there, and the functionality it provides is absolutely incredible, yet it's really, really easy for anyone to walk up and just start using without any instruction at all. And this is a picture of the interface during a movement, and you can change this look, if you will, anytime. So you'll notice that you can see your left and right side. So you can compare your force output in real time. It's showing you in this screen your max force in a repetition, showing your max force per set, how many repetitions. Here's done 67. What is your calories per rep for the last, and what's the total calories? Very, very motivating to really see in real time and get an accurate display of what kind of caloric expenditure is occurring while you're weight training. And to my knowledge, one of the few technologies that's going to provide that out there. History of isokinetics, as we said, they've been out for a long time, over 30 years, tons of peer-reviewed research on isokinetic exercise, probably more than anything else. And they're the basis. Isokinetic machines are called dynamometers often, and they are the basis and used as the standard to test strength increases within other studies. So there's just massive amounts of data on isokinetic training and comparing it to other forms of training. So isokinetic's been used for a lot of reasons: collecting and creating norms, classifying muscle performance, looking at torque, efficiency. It's used to measure the efficiency of treatment. So it is the measuring standard by which you judge other resistance training methods. And it generally quantifies exercise and resistance exercise in a way that we can't do with anything else. Evaluate the effects of all sorts of training things. Really, really heavily used, lots of utilization, and a tremendous amount of data. So we know a ton about isokinetic training. It just hasn't been able to be deployed in a functional manner till now. So what are some of the key findings from all this isokinetic research? Concentric-only isokinetic exercise, like DMX, has been shown to increase eccentric strength and result in significant muscle hypertrophy. In other words, yes, you can increase muscle size with isokinetics, and there is tons of evidence validating that fact. Same thing on the eccentric side. You also increase eccentric strength even though you're not doing any eccentric work. Now, we wouldn't say that we'd recommend you do no eccentric work in an ideal world, but the fact is that this modality is going to improve strength at every level. Isokinetics allow you to generate higher forces at higher speeds without getting injured. This is a big deal, and it's not possible with other resistance methods where we have something accelerating, such as free weights. We can do that, but there's lots of risk there, and being able to do this with no momentum or changes in inertia is going to allow the athlete in particular to train the neuromuscular system to be able to produce high forces at high speeds, which is obviously very valuable. On most things you can accelerate, on most resistance training methods you can accelerate and use momentum. This just simply is not possible at all. The muscle has to produce force at each and every point in the range of motion, and it does not allow any momentum to be generated. Other key findings. So there's significant strength increases from many different combinations of movement speeds, repetitions per set, and number of sets. So there's many, many, many different possible combinations, and there's many of them have been shown to work, just like other training methods like free weight, for example. Research has also shown that strength gains occur when performing as many repetitions as possible in set periods of time, such as one set of as many reps as possible in 30 seconds. So if you do CrossFit, for example, you know the as many reps as possible or the time set. That methodology, when applied to isokinetics, has also been shown to increase strength. Concentric isokinetic training, like DMX, has also been shown to increase strength when tested by other strength training methods. So one of the criticisms you hear of isokinetics is, yeah, you can do it and get stronger, but your strength is only improving isokinetically. That's just not true. That's not what the research shows. The research has shown in many, many different studies that, in fact, strength that you build isokinetically does show up if you test the person, say, with isotonic training or with isometric training. Now with all training, including isotonic, isometric, eccentric, and isokinetic, whatever you're doing, you're obviously going to always get your best results on a test if you train with that modality. But the fact is isokinetics have been shown to improve strength in these other ways as well. Optimal sets and repetitions. There's been a lot of studies trying to get that, and there's really been no firm conclusions. And I would say that it's probably the same thing when you look at resistance training in general. There's lots of different variations, and they all kind of work at some level depending on who we're talking about and where they are relative to their genetic potential. Although there were different conclusions based on different research, there was a consistent agreement that the number of repetitions appear to have little impact on increases in peak torque. What does this mean? It means that whether you're doing sets of 5, 25, or 30, or 30-second sets, or a minute sets, or a minute-and-a-half sets, they all are going to tend to allow you to improve your peak torque, or the force that you can produce at the end of the lever system. So it all kind of works again. There's lots of different ways that this can be deployed in strength training. Other key findings. Research in isokinetics has shown that, in general, longer rest periods tend to allow more optimal development of strength and power, while shorter rest periods allow for more optimal development of muscular endurance hypertrophy. And of course, this matches what you see in the literature about isotonic training, free weight training, variable resistance training in terms of the relationship between work and rest. So what you see there follows through to isokinetics. No one single optimal training speed for isokinetic training. There's no one magic speed that's going to do everything. That's also been looked at intensively in several studies. Some research shows that there's little evidence to favor a particular speed when considering gains in peak force. In other words, if you just want to gain the ability to produce as much force as possible, it's not necessarily that there's one magic speed, as you can see here reflected in this slide and the results of the study that it's summarizing. Power development. So when we're talking about power, we're talking it's different than strength. So strength is the maximum force a muscle and muscle group can generate, but power introduces time. So it's defined as force times distance divided by time. So the rate of force development to be powerful is important, and it's important not just in sport but in everyday activity and athletic events. Rapid force development is a key goal and a worthy goal for many people who are doing resistance training. Trainers often use lighter weights moved quickly to train for power, but this greatly increases momentum, and there's an accompanying increase in risk of injury when you're doing this type of training. The same exercise done using isokinetic resistance eliminates almost all the momentum and the need to decelerate at the end of the movement, which allows users to safely work on producing more force at higher speeds. So that theme again, we can work at different speeds, particularly higher speeds, safely, teach that neuromuscular system to produce higher levels of force at high speeds safely. Kanisha and Miyashita studied different groups training at different speeds and result in changes in power at different speeds. Although the study used different repetition schemes for different groups, and this kind of limits our general conclusions, it appears that a medium speed, which is expressed in degrees per second of movement, is best for gains in power across all speeds. But again, since we can train at multiple speeds, the best solution, as we're going to see, is not to train at one speed, is to train at more than one speed. Isokinetic training at a fast movement speed, as we've said several times, results in increased strength at a fast speed of movement to a greater extent than training at a slow speed of movement. However, because in most athletic endeavor, or in many athletic endeavors, we want to be able to produce high loads as well, we're probably going to want to spend time at slow movement speeds where we can produce the highest levels of force and optimize our time under tension along with the high-speed workouts, or mix them within one workout. Isokinetic velocity spectrum training, and that's what this is really referring to, training at multiple velocities within the spectrum of possibilities. So we want to mix and match for optimum development. So to create maximum power with high loads, you need to be very strong, which means you're going to have to train at slower speeds with correspondingly higher muscular force and higher loads that you're generating through the isokinetic system. The best way to do this, though, again, is to train in several places within the velocity spectrum, high and low. You can either do that through one workout focused on slower speed, higher force development, and another workout with higher speeds and lower force development, but focusing on producing higher force during speed, or you can mix them together within the same workout, obviously. So studies have consistently shown that isokinetic training improves athletic performance, and established tests related to athletic performance such as increase in vertical jump, tennis serve, and 40-yard dash and softball throw. So it's important to understand that there's been direct evidence that isokinetic training does improve these accepted measures that are clearly related to athletic performance. So it is absolutely a viable and proven athletic training modality, particularly in this functional layout that we have with DMX strength. Isokinetic training versus direct external constant resistance, or say free weight training. And there's been studies comparing these two. Most have shown great specificity and improvement. What does that mean? The people who lifted with free weights got stronger on free weights. The people who lifted with isokinetic training got stronger isokinetically. Okay, that's not a surprise. That's true of just about any training modality. However, isokinetics have been shown to increase isometric strength considerably more than dynamic external constant resistance training or free weight training, which is very interesting. So it's not completely specific. When we use a third-party surrogate to measure strength increases, isokinetic training actually outperforms free weight training, and this is definitely surprising. It was a surprise to me anyway. So the studies that have been comparing this dynamic external constant resistance or free weight type training and isokinetic training have shown no clear superiority of one over the other. So free weights are not, for example, superior to isokinetics, or vice versa for that matter. So let's talk about some strength training guidelines. How do you use DMX? And this is geared towards trainers understanding how to best utilize this tool. So initially, we're going to talk about acclimatization and your initial progressions. Like everything new, the person has to get used to it. So because there's no inherent resistance, the user's got to create the resistance when matching and attempting to exceed the speed setting. Very important to remember this, because we don't want people to move so slowly that they feel no resistance. And some people do that depending on the setting until they're coached not to do that. No jerking. Just like everything, we don't want to jerk into the movement, because at the beginning of the movement, as we try to move it faster than it's set, it won't move, and we generate joint trauma by doing that. Moderate movement speeds, which correspond to intensity settings on the machine between 8 and 12, are probably the best place to start, because the load, you'll feel the load quickly, but you'll still have smooth movement. If you do high speeds, this is odd, but settings below 6, which are higher speed, they feel lighter, but in fact you're setting the movement speed higher, they're going to demand a whole lot of control. Now slower speeds, where we set the intensity above 12, so the motor's set really slow, are so slow and they don't allow any kind of speed and movement that people can have difficulty moving through a repetition smoothly. So again, start people in the middle. 8 to 12 is a great place to start it when you're in doubt. Optimal intensity settings are specific to specific movements, and ultimately, as the client progresses, you're going to probably want to use multiple intensity and speed settings. Remember, intensity and speed is the same thing in DMX. So over time, you're going to want to use more than one setting to optimize the neuromuscular development of the client. That's one of the advantages, one of the things we can manipulate with DMX that we can't manipulate anywhere else. So what are the acute training variables when we're using DMX as a strength training system? Your standard things, your standard variables that we use, obviously number of sets. How many sets? How many repetitions per set? And the number of exercises. In general, with new users, just like with any new user on any modality, we want to initially focus on volume progressions. What does that mean? Focus on progressing by increasing, doing more repetitions, and or more sets, and or more exercise. So we're increasing the training volume till we get that where we want it to be. Weekly training frequency. Consider, you have to do this properly. How often do you do DMX? You have to consider everything. So what's their overall weekly training load? What is their fitness level, and what are their goals? Rule of thumb for most users, 2 to 3 sessions per week is a good starting point, and then adjust from there. Workout duration, how long? Again, you have to consider the goals for each particular workout. What is the overall program goals? What is their current fitness level? And what is their overall weekly training volumes? There's no set answer to that question. Let's continue our discussion of acute training variables. One of the key acute variables is the movement speed setting, which is controlled via the intensity knob. Slower movement speeds, which corresponds to higher intensity settings, allow a greater force production and tend to more quickly fatigue a muscle or muscle groups. However, when you're doing a slow movement speed, which is a high intensity setting on the machine, the movement speed is slow, the user ends up performing less repetitions that are higher speeds, which also affects overall exercise intensity and their rate of perceived exertion. Now, higher speeds, which is lower intensity. I know that sounds odd, but that's exactly what it is. Higher motor speeds on DMX optimize the ability to produce force at higher speeds. But if your goals include generating power with significant load, time must be spent working at slower speeds as well as faster speeds so that you maximize strength gains, as well as doing sets and workouts done at higher speeds. You want to work at both ends if those are your goals. Mixed speed workouts can also be a very productive way. So with some done starting with a higher movement speed, progressing to a slower movement speed, or more commonly, you start with slow speed set or two, and then you finish off with higher speed sets. And we're changing that. We're using that isokinetic velocity spectrum within a workout when we're doing that. Work-rest ratio. As with all strength training, very, very important way to manipulate the stress and the progression of training. It's a key variable, and it determines what energy systems are being engaged during an exercise session. In general, for hypertrophy and endurance, we want a higher work-rest ratio will produce the best results. So that means minimizing rest, more work, less rest. We're gonna focus more on endurance and hypertrophy. Now, if we're looking for maximal or strength, we're gonna actually flip that on its head. We need a lot of recovery, so the work-rest ratio is going to be much, much lower when working on maximal strength or power. This ratio can be managed by doing time sets. So instead of doing reps, you can do time sets if you like, with timed recovery. Or you can also choose, it's really your preference as a trainer, to have a person do a specific number of repetitions per set with a set or variable recovery interval. There's lots of different ways you can use that work-rest ratio to manipulate the stress and progression of a workout. So some examples. Let's say your average, quote, toning and weight loss client, which is a very common client in gym. We're probably going to have a hypertrophy focus here. We're going to have a relatively high number of sets, reps, and exercises, and progression in these areas to maximize total work caloric expenditure. Because we're going to try to do two things at once. We're going to try to build strength, increase muscle mass, or at least maintain muscle mass, but we're going to try to maximize our work output so that we're burning maximum calories and fat during and after the workout with EPOC. Use a relatively high work-rest ratio for these clients to maximize total work done while maintaining a high metabolic intensity. good starting point, 1 to 2 work-rest ratio, and progress to be able to do a 1 to 1 and even higher ratios. Use varied intensity settings based on exercise selection and to keep client from plateauing. So you can change this at any time very easily during a set, during a workout, or between workouts. Deliberate heavy use of double concentric movements such as doing a lat pull down with an overhead press. This is going to enable them to maximize total work calories burned and maintain a high metabolic output during the workout. Workout duration for these guys is going to be maybe 20 to 30 minutes because this type of programming is metabolically very intense and you get tired quickly if you're working intensely. Workout frequency. 2 to say maybe 3 workouts of this type per week. You can add in other workouts with lower metabolic intensity that focus on power or strength that have a lower volume, a lower metabolic intensity, and a lower work-rest ratio. So you can mix this in with other forms of training. Now, if your program goal is purely muscle hypertrophy, you're also going to have a high number of sets and repetitions and exercise to maximize it. The rest ratio is going to be pretty high as well. It's going to be important to vary intensity settings here to target different type of muscle fibers, but more time spent at moderate to high-speed settings corresponding to mid-range to low-intensity settings to maintain emphasis on high work rate. We want to keep that work rate pretty high. Training frequency here, 3 to 5 days per week with introduction of split routines focusing on particular muscle groups or groups as client progresses. We're going to do more work per muscle group here, and we're going to vary that tempo a lot. Workout duration here is going to be 30 to 60 minutes for the client. Examples programming examples continue. Maximal power development. Here it's going to be just the opposite. The volume is going to be low with much lower number of sets, repetitions per set are lower, and total exercise is going to be lower per training session to allow complete recovery between sets to maintain high power output, because power development, remember this, is not a fatigue-generated adaptive response. If we get fatigued here, we're not going to be able to produce a lot of power. That's counterproductive to what we're trying to achieve if we're trying to do maximal power development. The work-rest ratio will also be kept much lower. So a decent starting point here is work 1 to 2. So if you did 1 minute of work, you're going to have at least 2 minutes of rest for initial work rest. But this can be and should be adjusted based on athlete's performance. It can be much longer. It could be 1 to 3, no problem. Remember, we want to optimize power output, not fatigue the athlete during these type of workouts. Movement speed is going to be kept high most of the time, lower intensity settings, which is higher speed, to focus on high movement speed with overload. However, at least 1 session per week, we'll need to focus on maximal strength development if the ultimate goal includes increased power with high loads. Remember that. Frequency is 1 to 3 sessions per week, and each power session should only be done when the athlete is in a recovered state to allow for maximum power and force output. The duration of these workouts can be pretty long because there are less sets, reps, and exercises, but the greatly decreased work-rest ratio increases the time between sets a lot, so they can take much longer. Maximum strength development, if that's the goal, what program goal? As above, it's going to be pretty much like your power, but you're going to keep the movement speed lower or slower most of the time, which is to say the intensity high, to do 2 things. What's that going to do? It's going to allow for maximum force generation, which is really important if I'm looking for max strength, and it's also going to increase my time under tension to teach me to produce more force for longer periods of time there. Bibliography here, works cited. This will be up on the internet for people to find this particular in a PowerPoint format. It's very easy to find under SlideShare under my name, Greg Moore. Hope you've enjoyed the lecture today on DMX strength and functional isokinetic training. And definitely look for the video on YouTube as well. It's an excellent video that really gives you a good intro to the product and what this product is all about and what it can do for you and your clients.